Hello, once again, welcome back to our lecture. In last two videos, we discussed certain basic concept about the subject econometrics, its subject matter, scope, and why we need such kind of a subject in economics. So today, what we are going to discuss is what is the methodology of econometrics. What we mean by methodology? Methodology is nothing but certain steps or stages that to be followed when we are doing certain econometrics experiment. When we do certain econometric investigation, we have to do certain step-by-step procedure. So what are that kind of steps? What are these steps that we are going to see in this lecture? Suppose the central government is proposing a reduction in income tax in order to boost the consumption. So before government proposing this kind of a policy changes, they have to do certain analysis. And suppose that you are hired by the central government to analyze what is the impact of this kind of a policy reduction on final consumption expenditure. So this is the task before us. What we will do, what are the steps we have to do, we have to follow. Okay, so all these steps together is known as the methodology of econometrics. Then basically we are having two different types of methodology. One is the classical methodology and another one is the Bayesian or modern econometric methodology. So what we are going to discuss in this portion is classical econometrics methodology. In this methodology, we have to go through 6 different stages or 6 different steps. First one, formulation of an economic theory or theoretical specification stage. In this stage, we have to specify our economic theory. As we have seen, econometrics is nothing but economics plus maths and statistics. Okay, so the first thing we have to do, we have to stick on or we have to focus is on economic theory. Okay, second one, specification of the mathematical model or specification of the model. Then third stage is the estimation stage. Fourth is evaluation stage, and fifth and sixth is the prediction and policy analysis. Okay, so all these 6 steps we will discuss in detail in this video. Okay, then we are coming to the first steps, theoretical formulation or theoretical hypothesis. Suppose what we want to learn in this, why we are hired by the government to study certain things. What is that? How a reduction in income tax and consumption expenditure are related. So we have to do that. We have to identify a proper theoretical framework that analyze this consumption and income pattern. As we know that, you might have learned in macroeconomics, there are large number of theories that are available in macroeconomics in order to describe certain consumption functions. Okay, then absolute income hypothesis there, then secular stagnation theory, life cycle hypothesis, permanent income hypothesis, and then Duesenberg's relative income hypothesis, then random walk hypothesis, then intertemporal choice theory. There are large number of theories are there. What we have to do is we have to identify which theory is properly explain the situation. What is the situation? Government is going to reduce the tax. How it affect the consumption? Clear? Yes. So tax, if the government is reduce the tax, it will increase the disposable income. Okay, so on the one side we are having disposable income, another side is we are having consumption expenditure. Okay, so you just think about which theory analyze the relationship between disposable income and consumption expenditure. You can easily say that it is Keynesian consumption function. It is nothing but the consumption level of an individual or a household is depends upon absolute current disposable income. Once again, consumption is depends upon absolute current disposable income. Okay, what's absolute means? What is current? What is disposable income? Absolute current disposable income. It is nothing but income minus your personal tax. Okay, that is available on a current period without comparing into any others. That means absolute, not relative. Current, not past or future income. Then disposable income, income minus personal tax. Okay, so he explained that consumption is linearly and non-proportionately related to disposable income. That we will explain later. Okay, then in order to explain this theory, he has put forward some ideas. Okay, then Gregory Mankiw called these ideas, or he categorized all these ideas into three conjectures. First one is the income is the only determinant of consumption, and interest rate doesn't have any role to play in determining consumption. Why he has made such kind of a conjecture? Have you ever think about it? Yes. Because before Keynes there was classicals. Okay, what they opine or what their idea about consumption is, consumption could be affected by the interest rate. If the interest rate is very high, then people will reduce their consumption and they have a tendency to save more. And due to this fact, there may be certain negative relation between interest rate and consumption. This was some idea which were given by the classicals. Okay, so the Keynes attacked this notion, and Keynes said that no, it is not like that. Interest rate doesn't have any role to play in determining one's consumption. It is only the income determining the consumption. Which income? Current disposable income. Clear? Yes. And second conjecture is, whenever income increases, APC will down. What does it mean? What is APC? APC is nothing but C by Y, consumption divided by Y. Okay, so it is always going down when income increases. It means that whenever your income increases, consumption will also increases, but the consumption will not increase at a rate that the income increases, always less than that of that. Okay, for example, if you suppose that your income is 100 rupees, your consumption now is 90 rupees, you are saving 10 rupees now, your income increased to 200 rupees, your consumption should not increase to 180. That is a proportionate increase. Okay, below 180, that will be non-proportional. That means your consumption may increase to 170. Okay, it should not be 180 and 180 above. Okay, and you will save more. When your income increases, you will reduce your consumption and you will start to save more. Because of this fact, APC will always down when your income increases. Clear? This is the second conjecture. Third one, MPC. MPC is nothing but changes in consumption due to changes in income. This is always lies in between 0 and 1. Okay, why he has made such kind of an assumption? Because if the value of MPC is going beyond 1, what does it mean? If a person income is 100 rupees and if it is increased to 200 rupees, then if MPC is beyond 1, then his consumption will increase more than 200. Okay, more than proportionate. Okay, so that will never happen. Okay, so this was the main idea of the Keynesian consumption functions. Okay, so this we have to specify. So we are analyzing whether the tax rate decrease, the proposed tax rate decrease, how it will affect the consumption pattern. We are going to analyze this problem using Keynesian consumption function. Okay, so we are saying that consumption depends on income. Our consumption depends on current disposable income. This is our theoretical model, or this is our hypothesis. This we are going to check. Okay, so this is the first stage, the stages of theoretical formulation. And then second stage, coming to the model specification. So all these three conjectures which I have given can be explained either through a graphical, either through graph or through a algebraic model. So what is an economic model? Economic model is nothing but a simplified representation of a real world or real economic phenomenon. We are going to simplify a big fact into certain numbers, or we are analyzing, or we are transferring or converting that big idea into a graph. Okay, this idea is known as economic model. Economic model is nothing but simplifying the real economic phenomena or real world economic phenomena. How to simplify? Either we can adopt graphical representation, or we can do certain mathematical specifications or mathematical equation. Okay, so how we can convert the three conjectures into a graph? Look at this graph. On the vertical side, we are having consumptions. Horizontal side, we are having income. Okay, so whenever income increases, you can see that consumption is increasing. Okay, and here why we are having why our graph is starting from the mid, almost the above the zero, or about the origin of the graph? Because of the idea given by the Keynes, that is the yes, autonomous consumption. Okay, that means even if a person is not having an income, he has to consume. Okay, so how much he will consume, that amount is known as autonomous consumption. Okay, that's why you just check the in the zero itself our graph is starting. Okay, but certain above. Okay, this means that the area of in between origin and the alpha written in graph, this is the amount of autonomous consumption. Okay, yes. Then the graph, you can see that it is not starting from the origin, it is starting from the almost the middle. Okay, or above the origin. Why it is so? Because we assume that less than proportionately. Okay, if it is proportional, then it will start from the origin and the slope will be always equal to 1. But here the slope is always less than 1 and above the 0. Okay, that means it shows that MPC. Okay, so using this graph we can measure MPC as well as autonomous consumption. Clear? Yes. Then an economic model in the form of an algebraic or a mathematical equation help us to describe a relationships and a series of other behaviors associated with this relation. Let me take an example. Okay, as we know that the quantity demand for a commodity depends on many factors. Okay, so when we describe such kind of factors, it will take a lot of time, it will consume more space. Okay, so how we can simplify that one? You convert that statement into an equation. QD is equal to function of P, price, then price of related commodity, income of the consumer, taste and preference. using 5 letters and some notations, mathematical notation, we can describe a series of behavior associated with the demand. That is the advantages of economic model giving to us. Okay? Yes. And one more thing I would like to say, that if there is a no mathematical equation that linking the relationship in the theory, such kind of theory we cannot empirically verify. Okay, so in order to empirically verify a relationship or theory, there should be a mathematical equation, or there should be a mathematical expression. If there is no mathematical expression, then we cannot study scientifically using data or using econometrics. Okay, yes. Then you tell me, what is the form of the function? You look at this graph. What is the form of this graph? Is it constant function, straight function, or linear function, quadratic, cubic, or exponential function, or logarithmic function? What kind of function is this? It is, we can say it's a linear functions. Okay, so linear function is nothing but a function in which the parameters or the variables will be appeared with power 1. Okay, that means if we have a straight line other than horizontal or vertical, then it would be a linear function. Okay, if it is a straight line or a horizontal line, it is a constant function. Okay, so here we can see it is a linear function. Okay, that's why we are saying that Keynesian consumption function is a linear and non-proportional. If it is linear and proportional, then it would have started from 0 itself. Okay, but just not like that. Okay, so we are deriving the functional form of this model, okay, from our theory. Theory says that it is linearly related. Okay, so we know that the equation or the graph would be, or the equation will be a straight line equation or a linear equations. Okay, yes. So what kind of, suppose if you are estimate the cost function, what will be the function? Cost function U-shaped. Okay, so if we want to get a U-shaped, what will be the function? Quadratic. If we have an inverted U-shape, Kuznets curve, if you want to verify the Kuznets curve, what would be the function? Inverted U? Yes, quadratic function. If you want to verify the total cost curve or the total variable cost curve, it is a reverse S shape. Clear? Then the graph will be, or the function would be cubic function. Okay, if you want to verify a horizontal line like perfectly elastic or perfectly inelastic, then it would be a constant function. Clear? Yes. So what kind of a function we have to use is depends on what our theory says or what we can introspect from the theoretical or from the common sense. Okay? Yes. So this is the mathematical or model specification stage. Okay? So once we have a pure graphical analysis or pure graph, from the graph itself we can derive a mathematical model. Okay, look at the first graph that we analyzed. Okay, after that you can see that y is equal to function of x. Okay, y is our dependent variable, x is our independent variable. We will discuss later. Okay, what is this dependent and independent? It says that y means consumption expenditure is depends on income. Okay, yes. Then on the next side, next line, we can see that y is equal to a plus bx or a alpha plus beta x. Okay, in the above, y is a function of x. It means that consumption expenditure depends on income. Then why we are having the straight line equation? Why we are not? Why don't we need this functional form? And why we converted this functional form into a linear equation? Because the functional equation will just tell you whether these variables are related or not. It won't give us what is the direction of the relationship. Okay, Suppose if I am the next line, if I am writing Q is a function of P, here Y is a function of X. Consumption depends on income, quantity depends on price. Both are giving the same notations, and when we look at both equations, both are looking same, but both are having the different meaning. Okay, Q and price are negatively related, consumption and income are positively related. So this kind of a direction we cannot get when we look at the functional form. That's why we are converting the functional form into a appropriate functional form. Okay, so the next we have converted this form into y is equal to alpha plus beta x. Okay, so this tell us y is consumption means an intercept, that is called autonomous consumption. Okay, what will be the consumption expenditure when our income is equal to 0? Then plus, this plus means that y and x are positively related. Into what extent? That is given by the beta coefficient. Okay, so the beta coefficient give us on what extent this, or how many percentage this y and x are related. Okay, that means if income increased by 100%, how much consumption will be increased? This would be given by this beta coefficient, or what we call theoretically marginal propensity to consume. Okay, yes. Then now we have specified a mathematical equation, y is equal to alpha plus beta x. Clear? Yes. But there's a problem here. What's the problem? The mathematical model assumes an exact or deterministic or functional relationship, whereas most of the economic relationship are inexact or statistical or stochastic. Deterministic versus stochastic, exact versus inexact, functional versus statistic. What does this mean? That it means that our mathematical model assumes that consumption will be only depends on income. Consumption will only depends on income. That's why I call it as a deterministic only. There are no any other factors that will affect the consumption. Okay, but the problem is that in economics we cannot have such kind of a relationships. Okay, we cannot tell, we cannot exactly tell a relationship because we are dealing with humans, not with laboratory experiment. Okay, so the deterministic relationship we can have in pure natural sciences, but in social science we cannot have a deterministic relationship or exact relationship. In always the economic relationship are inexact, or what we call as stochastic. Okay, yes, let me tell you in more detail. Look at, can you suggest any other determinants of consumption other than income? In mathematical model we assume that the consumption is the only determinant of the income is the only determinant of consumptions. Okay, can you suggest me any other variable other than this income that will affect the consumption? Yes, lots of variables are there. Size of the family will affect, the wealth of the family will affect. Okay, the how many number of people are employed, unemployed. Okay, how many persons are there in this household, how many members are there, what's the size of the family. Okay, where this house or household is located, is it in urban location or a rural locations? All these would affect whether this person is married or not. All these will affect the consumption pattern. Okay, so in mathematical model we assume that consumption income is the only factor, but in reality not only the income, there are large number of other factors. Okay, then there are certain factors that we cannot reasonably observe or measure. There are certain factors that even we cannot measure. You just take the wealth. Everyone knows that the wealth will be, the consumption will be affected by the wealth. If those who are having higher wealth will consume more. Okay, but tell me how to measure the wealth. On the base of wealth, on the base of land? If it is on the base of land, which land? Okay, how to price the land or how to evaluate the land? Okay, then on the base of gold ornaments, on the basis of houses or gadgets used, on the basis of house, the size of the house, on the what basis, on the basis of the investment in financial markets. So we can measure the wealth in different way. How to measure it? There is a problem. Okay, and there are some other variables that affect our consumption, but that we cannot even list. For example, I have given you 500 rupees each to everyone. Then me and you went to a restaurant and I told you to buy whatever you want to buy. I have given you 500 rupees, it is your income. You are going to consume using this income. Okay? Will you consume in the same way as others? That means there is a juice in that shop. All of you will order the juice? No. If all of you are ordering the juice, then your behavior is exact, deterministic. But we are all human beings. We cannot have same taste and preference. Some people may order tea or coffee or Horlicks or Boost. Some may be juice, cake. Okay, this means that human behaviors that we cannot forecast or that we cannot predict using a mathematical model, because mathematical model assume that your consumption is only depends on your income. Okay, but it is not income. There are some other factors, and there are some factors that we cannot list out. Okay, then why we are having different tastes that we cannot list as a variable. Okay, so we are having three problems here. One is there are some other factors that we are not including in this equation. Okay, that may affect our consumption. Second one, there are some variable that we cannot measure properly. Third one, there are certain variables that will affect our consumption, but we cannot list out. Okay, but as we know that all these variables will have an effect on our consumption, so we have to account all these effect. Okay, so what we do? Here comes the econometric model. Econometric model is an answer for this question. What is that? Econometrician would modify our equation or our deterministic model simply adding a variable into that. What is that variable? It is called the U term. Okay, so we are just converting a mathematical model into an econometric model, simply adding a term or a variable called U term or disturbance term or error term. There are different names for that. If you look at different books, you can see different names. Okay, disturbance term, error term, these are the most common word. Okay, U term or epsilon term. Okay, then what this U will capture? U is a random variable which represent all other omitted factors from the equations, errors in measurement of the variables, and other factors that affect our consumption, but we are not explicitly including in our equation. We have included only income. Y is equal to A plus B x u or alpha plus beta x u. Here we have included only one variable, income. There are other variables. Size of the family we are not including. Where these fellows are locating we are not including. how many members of the families are there, we are not including. We are omitting all these variables and putting one term called U. There are wealth, but we cannot measure it. So what we are doing, we are putting a variable U. There are certain variables that even we cannot say, that also we are putting, that also we are capturing by U. Okay, so U is a random variable that will capture all other variables that are omitted from our models. Okay, but that will have a impact on your consumption. Okay, so this U will capture all other omitted variable from your models. Okay, and what will be the impact of all other omitted variables from these models, that will capture by this U term. I hope it is understood. Okay, and dealing with this error term is the most important exercise in econometric analysis. So from this onwards, we are dealing with how to deal these error terms. What is the error term is? What are the things the error term will capture? How to measure these error terms? Okay, what are the assumptions related to these error terms? Okay, and what will happen if certain assumptions about this U is violated? These are all is the subject matter of econometrics, more specifically. Okay, yes. Then apart from U, you can see an alpha and beta in this. What is that? It is the parameters. Okay, so we will discuss these parameters later, and you can see I am putting a alpha and beta. In some books they have put AB or A1 or B1 or B2, something like that. Don't confuse with that. It is simply a letter. You can put AB, you can put any number, any Greek or any Latin or whatever the letter you want, you can put it. Okay, yes, so it's a purely a letter to denote a parameter. Okay, so alpha is a parameter or what we call intercept. Okay, then beta is another parameter that's called a slope parameter. Clear? Yes. So this is the econometric specifications. Okay, so we discussed theoretical formulation, then we discussed specification of the model. In specification of the model, we first discussed mathematical specifications and the problem with the mathematical specification, then why we need a econometric specification, then how to modify a mathematical equation into a more econometric specifications, and what is U, what are the things this U will capture. Okay, I hope it's clear now. Yes. Then we will discuss what is this third stage, the estimation stage. Two stages are over, two steps are over, then we are moving to the next step, estimation stage. Okay, so in order to estimate certain things, what we need first, we need to have a data. Okay, without data we cannot estimate. We are having a theory, we are having a model, but we don't have a data. We cannot estimate it, we cannot verify it. So we need data. Okay, what a data is? Okay, you look at this graph, you look at this screen, you can see I am collecting the data from 5 households. Their consumption is given, their income level is given. You check the first household. One is the first household. Their income is 300 rupees. They are consuming only 220 rupees. Remaining 80 rupees they are saving. Okay. So in this graph, there are 3 different elements or 3 different concepts are underlying in this graph. The first one is the element. What is an element? An element is a specific subject or object about which the information is collected. We are collecting the information from household. So this household is the element. Clear? Yes. Then a variable is there. What is a variable? A variable is a characteristics under study that assumes different values for different elements. So we are not studying about the household. We are studying about what is the consumption and income pattern. So consumption is one variable, income is another variable. Clear? Yes. And this variable assume different values for different elements. You will have a different values for different elements. Okay. Then what is an observation? A value of a variable is an observation. 220 is an observation. 220, 300 is an observation. Okay? Yes. So the next thing you have to understand that what's the data? A series of observation is known as data. Okay? A series of data for one variable or two variables is known as data. Okay, I hope that's you understood what a data is. Clear? Yes. So in econometrics or in reality, there are two types of data. One is the experimental data and the another one is the non-experimental data. What is the difference between experimental data and non-experimental data? Experimental data means the data collected or generated in laboratory environment in the natural science. So in science, in purely natural or environmental science, they are making or they are converting or generating certain variables using some laboratory experiments. Okay, this is the experiment data. The one of the most advantage thing is that these data are purely quantitative and they can manipulate the variable and its measurement. Okay, once a variable that is created in a laboratory experiment, that they can manipulate it and it's purely quantitative. Okay, so most of the natural science data are experimental data. The data has been generated using from a laboratory experiment. Okay, but not experimental data are the data accumulated or generated or collected from individual firms or different segments of the society. Okay, so not experimental data are the data accumulated through a controlled experiment on individual firms or segment of the society or economy, or these are of the observational data. Okay, this means that we are reporting actual happenings. Suppose how many persons are there in a family? This is our question. We are going to collect the data. How many persons are there? There are 10 persons. We can only report 10. We cannot manipulate it. Okay, but in using certain instruments in chemistry, by adding certain things in, I don't know whether what to say, so they can generate certain things. Okay, and by adding certain other things, they can convert the same thing into different levels. Okay, so by adding or by doing certain experiment, they can convert their data. But in social science, we can only report the data and we cannot manipulate the data. Okay, so the most of the economic and social science data are non-experimental data, or what we call observational data. Okay, but nowadays, as you know that there is a branch of experimental economics or behavioral economics. Okay, so in behavioral economics, they are generating certain data. Okay, that means suppose we want to measure how education and poverty are related. What they have to know, they will identify certain pupils who are in poverty or are suffering from poverty, and they will give them educations, and they will wait for 10 or 15 years what happened to that fellows. Okay, then after 15 years they evaluate what happened to their poverty. This is some kind of an experimental approach to social science data. Okay, but nowadays most of the data are experimental data are generated by the science or purely natural science people, but nowadays the economics also entered into the field of non-experimental data, especially in behavioral economics. Clear? But other than this behavioral economics, almost all the data in economics are observational data. We cannot manipulate the data. We can only report what actual data says. Clear? Yes. Then we are having, what is the structure of the data? Okay, so we have decided, we have find out the theory, we specified the mathematical model, econometric models, then we decided to go to data to collect the data. We decided to go to non-experimental or observational data. Okay, yes. Then what would be the structure of our data? This is the next question. What would be the structure of our data? In economics, we are having 4 varieties of data. Okay, they are cross-sectional data, time series data, pooled cross-section data, and panel or longitudinal data. There are 4 types of data in econometrics: cross-sectional, time series, then pooled cross-sections, and last one is longitudinal data, or what we call panel data. Okay, so what is a cross-section data? A data collected is a single dimensional data collected at a point of time from individual, household, firms, cities, states, countries, or varieties of other units taken at a given point of time. Okay, so the data collected at a point of time. What is this at a point of time? Okay, for example, several families may be surveyed during different weeks within a year. Suppose if we want to study, we want to get the data about consumption and income of different families, but we took almost 1 year to complete the data collections. Okay, but still it is cross-section, because here we don't have a time element in our analysis. We are having cross-sectional units, not a time element. Okay, so in cross-section unit we don't have a time element. We are collecting the data at a point of time from different units. Okay, these different units are known as cross sections. Okay, so even if a survey took 1 year, all these 1 year will be taken as a one time, okay, not the several time. Okay, so you look at this, you look at the cross section data are obtained using a random sample. Okay, so you have to understand that the cross section data are collected or can be collected, or if a data is a cross section data, then we have to understand that that data is collected through a random sampling techniques. Okay, that means if you have obtained 500 data from household, 500 household data we have collected in our area where there are more than 1000 or 2000 household others. So this 500 sample is collected through a random samplings. Okay, so this is the one of the crucial assumption of cross section data. Okay, and one of the main feature of this data is that the order of the data, it doesn't matter. That we have to understand that. Okay, that means if I collected the data or the data from household which is very nearest to me, and the last one I have collected from somewhere else. Okay, so this type of an ordering will not affect you in your analysis. Okay, so if you collected some data in the first, if you put some data in the first and some data in the last, it won't change the result. Okay, so suppose in a class there are 500, there are boys and girls. Okay, there are from different backgrounds. Okay, if I took girls first then boys, or first boys then girls, it won't change the result, because whatever the order you may put, it won't change the result. Okay, yes. So once again I am repeating, cross section data is the data, single dimensional data, mean there is no time dimension, single dimensional data collected at a point of time. Clear? Then the cross section may be the individual, household, firm, industry, state, different countries, or different any other units. Okay, then when we say that there is no time dimension, it means that even if we took many years to complete a data collection, still all such kind of data is considered as a one unit. Okay, then all these cross section data should be randomly collected. Order doesn't matter. Okay, then this kind of a data are extensively used, especially in applied microeconomic fields such as labor economics, state and local public finance, industrial organizations, urban economics, demography, health economics, or industrial economics. Okay, so these cross-section data are we regularly use this kind of cross-section data in applied microeconomic field. Clear? Yes. And in order to how we can understand what type of data a researcher has used, look at in the variables. After variable, if there is a subscript called I, then we have to understand that these techniques or this estimation has been done using cross-section data. Okay, so cross-section data is usually denoted by the subscript I. Okay, yes. So how would be the data look like? Look at the first example, 1 2 3 4 5 6, income, expenditure. Okay, so income is one variable, expenditure is another variable. Household, 1 2 3 4 5, first household, second household, third and fifth household. Okay, then if you put first household last household first, the result won't change. Clear? Yes. So first, second, third, fourth, fifth, this is our cross section. This next two columns are the data. Okay, look at the next one. Here we are collecting the data from labors. So in the first case it is from household, so household is the cross section. The next session we are collecting the data from labors, labor wage, education, experience, their gender, their marital status. So 1 2 3 4 5, what is mean by 1 2 3 4 5 here? It is first labor, second labor, third labor and fifth labor. Clear? Okay, so here we don't have a time dimension. Okay, so this will be more clear when we discuss the time series. What is time series? Time series is a two-dimensional data. Okay, or data collected for the same variable in different period of time. We are collecting the data for a variable but in different period of time. Okay, so this period may be decennial, annual, 6 month, biannual, quarterly, monthly, weekly, or fortnightly, hourly, secondly, whatever may be the time, no problem. Okay, but here we are collecting the data on the same entity or same variable in different period of time. Okay, to look at the case GDP. What is GDP? Gross domestic product. Okay, is a variable. Okay, how if you have seen the GDP data, how it look like from 1950 onwards, 1951 we have a GDP figure, 1952 another GDP figure, up to 2019 we have a GDP. Okay, so we are having only one variable called GDP, but for a GDP we are having different values at different period. Okay, earlier we are having the data on different cross sections, household 1, household 2. Here First year one data, second year another data, third year another data. Okay, here the time is changing. The earlier section where the unit changed or the household changed. Okay, so here we are having a time dimension. The data are chronologically ordered. That's why the ordering is very much important. Okay, we cannot write 1951 this much GDP, then 2001. We cannot say like that. There should have a GDP. There should have a proper ordering, chronological ordering. Okay, and cross section we denoted I, whereas time series we usually denoted by T. So XT, YT means what? Y data collected at a particular time period. So we have to understand that it is a time series data. Clear? Yes. And when we discuss the time series data, we have to take care of lots of other things. Different problems will be encountered like seasonality, stationarity, all such things. Okay, so it is not easy to analyze a time series data when we compare to the cross section data. Okay, that we will learn. Okay, look at the data. Year 1951, 52, 53 up to 2019. Look at M3 money supply, GDP at factor cost. Okay, so we are having two variables, M3 and GDP. This same data has been recorded in different period of time. Okay, so this is what we call time series data. Okay, the next thing is pooled cross sections. Cross section is pooled. What does it mean? The data with both cross sectional and time series features. In this data we are having the feature of both cross section and time series. For example, you might be aware about NSSO's round conference or round surveys. Okay, so there are two surveys, 65 round survey and 66 round survey. What the NSSO is doing in these surveys? They are taking certain samples and they are surveying the sample for variables such as income, saving, family size and so on. Okay, so in 65th round data, they are collected the data 10,000 data from different states on different variable like income, saving, family size and so on. In 66, what they are doing? They will do the same analysis, but the unit may be differ. Okay, suppose in the last 65th round they have collected the data from me, but in 66 they may not collect the data from me. Okay, they will have another samples. Okay, even though questions and survey methods and questionnaire are same, they will collect the data in different period from different cross sections. Okay, so here we are having time, two time. 65th is maybe in 2005, 26th 2010, the 5 years gap. Okay, then cross section is also different. They have in the earlier time they have collected the data from some peoples, and this time they are collecting data from another. Okay, yes. So in this we are pooling the cross section for different years. Okay, and this pooled cross section can also be analyzed using some standard cross section unit, cross section econometric methodology, but there are certain problems when we deal this kind of a data that we will analyze later. Okay, so how this data look like? You can check this table. We are having 500 data, 1 2 3 4 5 up to 500 data. Okay, but look, 1 2 3, these 1 2 3 data are collected in 1 year 1993. 1993 first household, 1993 second household, 1993 third household. Okay, up to we have collected 250 data from 250 household in 1993. Okay, so we are having 1 year 1993, for 1993 we are having 250 household. Next 1995, another year, in 1993 there are another 250 people. In total we are having 500 data in 2 different periods. Okay, so this type of data is known as pooled cross section data. Clear? Yes. So there are one more thing is there. There is a small difference. This is most confusing thing when we look at the different data. Panel data or longitudinal data. Okay, so a panel data consists of a time series for each cross-section unit in the data set. We are having time series for each cross-sectional unit in the data set. Okay, for example, wage, education and employment data for a set of individual followed over a 10-year of period. Okay, or you just take the GSDP, gross state domestic product, which is a state GDP. Okay, then we are having annual GDP data, time series annual GDP data from 1951 onwards for different states. Kerala, Tamil Nadu, Karnataka, these are all cross sections. 1951, 52, 53, all time series. Okay, so here we are having time series on the one side and other side we are having cross sections. Okay, so this is also what? A combination of time series and cross section data. Okay, so you may have a doubt, what is the difference between a time series and a cross section data? Okay, so I will clarify that doubt first. In pool data, the observation in each cross section do not necessarily refer to the same unit. It means that in each period the sample may be different. Okay, the samples are independent. That means in the last time they may have collected data from a household. This period it is not necessary to collect the data from that household. The house may be different, time may be different, house may also differ. Clear? Yes. So NSSO survey is just like a pooled cross section data. Whereas in panel data, the same cross-sectional units observed necessarily refers to the same unit. Okay, just like our population census. Okay, so population census is conducting every 10 years is conducting. Okay, so we will have a population data for different states at different period of time. Okay, here the states are same. Kerala, Tamil Nadu, all the same, but only the years are changing. Okay, but in the pooled cross section both year and cross section will change, but in panel data only the time will change, cross section will remain unchanged. Clear? Yes. So in both these, since there is an element of time in both pooled cross section and panel data, there will be a time element. Clear? Yes. Then after we decided to go with cross section, we will discuss cross section first and they will come to the time series. Okay, so most of the time series part we will discuss in the fourth semester or when we discuss the time series analysis or advanced econometrics. So in the basic econometric course we are mainly dealing with cross section data. Okay, so we decided to go with cross section data and we have decided to collect the data from household about consumption and income. Clear? Then what is next? Estimation. We have to do estimation. How to do estimation? What is estimation? Estimation is nothing but we are having an equation, econometric equation, where alpha, beta are parameter. Okay, find out a numerical value for this alpha and beta is known as estimation. Clear? How to find out the value for alpha and beta? If we get the value for alpha, it is consumption, sorry, autonomous consumption. If we get the value for beta, it is known as MPC. Okay, so getting the value for autonomous consumption and MPC is the estimation procedure. How to get the value? Large number of methods are available. OLS method is one method, regression method. Then maximal likelihood is another method. Okay, then moment based method is another method. So there are large number of different econometric methods are available. But in basic econometric course, we will only deal with OLS, or what we call regression technique. Okay, so we are having an equation y is equal to alpha plus beta x plus u. We have to find out alpha and beta. Okay, then if beta coefficient, or if the value for beta is lies in between 0 and 1, if the numerical coefficient between numerical coefficient of beta is 0.5, then we can say that Keynesian idea about consumption function is right. Okay, so if we got 0.9, then we can say that Keynes is right. How to do this? That we will check. How to do a regression analysis? That we will check. Okay, so I am doing this exercise with a view to with an understanding that you all study the basic regression techniques in your undergraduate programs. Okay, yes. So we will discuss the technique of regression later, but for just for introduction purpose, or for just introducing the estimation technique, I am giving this. Okay, so y, x, we are having consumption data, we are having income data. 1, 2, 3, 4, 5. Only 5 household is there. Okay, the first step is you find out the value for, find out the average consumption and average income. So you can see the in the slide, y bar is equal to 65, x bar is equal to 76. Okay, it means that y is consumption, average consumption is 65, average income is 76. Okay, then you have to find out the deviated y and deviated x, or small y and small x. Small y and small x means nothing but the deviation from the average. Okay, y minus y bar. Look at minus 10. Okay, y bar is 65, y is actual y is 55. 55 minus 65 is equal to minus 10. We can calculate all that. Then small x means actual x minus x bar. Actual x is, the first value is 60, 76 the x bar, so we will get minus 16. Okay, then you multiply the small y and small x, yx, 10 into minus 16, minus 10 into minus 16, 160. You get 160, 45, 0, 40, 180. Total is 425. Then you find out the small x square. Small x means your independent variable. Okay, it's square. So small x means 16. 16 square 256. Okay, then 256, 81, 165 and 324. You will get 726. Okay, so regression equations, we are having a regression equation. It is just nothing but beta value is sigma xy divided by sigma x square. Okay, how to get this sigma xy, sigma x square, that all we will discuss later, and we will derive this equation. Okay, so don't worry about it. Okay, so we got 425 divided by 726, 0.58. What is this? 0.58 is our MPC. Okay, so what is alpha? Alpha means y bar minus your estimated beta value into your x bar. So 65 minus 0.5853 into 76. Okay, so we have got 20.50. So we have estimated the model. How the model will look like? Y cap, or y hat? It means that we are estimated this model y hat 20.5 plus 0.58 x. Clear? Yes. So now we have estimated this model. Okay. So this is the estimation procedure using the regression analysis. The how we got this equation and all that we will discuss in the second module. Okay. Yes. So look at here. Our intercept is 20.5 and MPC is 0.58. How we can interpret it? First case, even if a person in these 5 members don't have an income, they have to they need minimum 20 rupees for their necessary purpose or unavoidable purpose. Okay, so they, in order to live in this area, they need at least 20.5 rupees. That is the autonomous consumption. Okay, then MPC is 0.58. What does it mean? If a person's income is increased by 100, their consumption is increased by 58 rupee only. The remaining amount they will saved. Okay, so if a person is income increased by 5,000 rupees, their consumption will be increased by 585 rupees, 585 rupees. Okay, so using this we can say one thing, that whatever Keynes said about MPC is right for this 5 individuals. What Keynes said, MPC is always lies between 0 and 1. So this is correct. Clear? Yes. So here now we have empirically proved that Keynes is right. Clear? Yes. And after this, we have got a value for MPC and intercept. But still we cannot believe this, because in statistics there are certain reliability tests. Okay, so we need to do certain precision or reliability test, and if all the test says that your result is fine, then only we can move. Okay, or sometime you have got this information, or you have got this MPC and alpha because of some measurement error or some sampling errors. Okay, so all that thing we have to check. So this is the evaluation stage. After the estimation stage, we have to go to evaluation. Okay, how to evaluate? You have to check whether your estimator is least. You have to check whether your R square is highest or not. You have to check whether your standard error or variance is low or not. You have to check whether your t statistic is close to 2 or not. You have to check whether your variable is efficient or unbiased, or whether it has a minimum mean square error or consistent. Okay, so you have to check all these criteria. Okay, all these criteria we will discuss later in detail. Okay. So then after evaluations, you might have learned the hypothesis testing in your advanced statistical course. Okay, so you have to test the hypothesis. Okay, so in our model, what would be the hypothesis? Income has no effect on consumption. The first assumptions, income has no effect on consumption. Okay, so similarly you can create as much as hypothesis you want to analyze or you want to get, and using the data and the result you can analyze the result, or you can find out whether your hypothesis is true or not using large varieties of tests, others z test, t test, f, chi-square. Okay, all these tests we have to use on a particular situation. Okay, we have to understand what type of statistics we have to use in this particular situation, that we have to use, and we have to check whether our hypothesis is true or not. Clear? Yes. Then after this, we are going to the fifth stage, forecasting. So one of the most important use of estimation technique is to forecast. Okay, forecast means nothing but to forecast or predict the future values of an economic variables. Okay, so we are having a large number of different forecasting tools. The regression techniques or OLS technique is one of the classical forecasting tools. Okay, so look at this table: 55, 60, 65, 70, 75. There is one more fellow is there. He is not claiming his consumption, but we know his income. Then don't worry, don't go to him, don't ask him again. You get his income, you predict his income using the available informations that we can do. Okay, because we have got 20.50 is the intercept, 0.58 is the MPC. Then you multiply his income, you know his income is 100 rupees, then probably his average consumption would be 78.5. Okay, so after the estimation we have to do, if we need to do forecasting or prediction, we have to do that. Okay, yes. Then the last stage, policy purpose. So why we hired by the government? To do a policy analysis. What's the policy analysis? Whether this tax reduction will increase the consumption of the people or not. If it is increasing, the how many percentage? Clear? Yes. As we know that the tax reduction will increase the current income, it will increase the expenditure by the amount of multiplier. Okay, you might have learned this government purchase multiplier and tax multiplier. I hope it is you are all read at least the Gregory Mankiw macroeconomics. Okay, basic ISLM part. Okay, in that he defined the multiplier. What is multiplier? 1 divided by 1 minus MPC. Okay, so whenever there's a increases in the government expenditure or a decreases in the tax, it will increase the consumption expenditure by the amount of multiplier. Okay, so multiplier means 1 divided by 1 minus MPC. So 1 divided by 1 minus, what's our MPC? 0.58. So it is 2.38. Okay, so we got the result. Okay, this is the duty of an econometrician. Then we have to suggest to government that if you increase the amount by this much, the consumption of the people would be increased by this 2.38 percentage. Okay, so this is we have got from just analyzing 5 peoples. Okay, so by adding more people into our analysis, we can increase the stability and the reliability of this estimator. Clear? Yes. Then after this you can do whatever the suggestion they want. Okay, you can analyze it. Okay, so this is the 4 steps or 6 steps that has to be followed when we are doing an econometric analysis. Starting, we need an economic theory. We have to specify, we have to formulate an economic theory. Okay, then we have to specify a mathematical model. There are problem with mathematical model, so we need to do econometric modeling. Okay, then we have to do an estimation. In estimation, the first step is data collections. Okay, then after hypothesis testings, then if our hypothesis testing is wrong, then you have to revise your data again, you have to estimate the models again, you have to do evaluations. Okay, so if your model is good, then you have to forecast, and finally you can apply this forecaster tool to in policy purpose or policy suggestions. Okay, so this is all about the classical econometric methodology. I hope the session would be helpful to you. Okay, please read the book. You can refer some book. I'll give you some books. Okay, this thing we'll discuss later. If you want to read some book, again I will give you some books. Okay, first one, Chris Book's Introductory Econometrics for Finance. It's a very good book. Okay, its soft copies are available. Then 2 Gujarati textbooks. One is the Basic Econometrics and Econometrics by Examples. Okay, then that is this book. Okay, I'll give you that. This is the Econometrics by Example. Okay, then one more book is there. It is Christopher Dougherty book. Okay, Econometrics, Introduction to Econometrics. Then this is very good book. which authored by Indian author Shankar Kumar Bhaumik and published by Oxford. Okay, so there are some other books also. I can, if you want, I can show you, but just not available in my table. Okay, so the Madala books and Wolde textbooks, a large number of textbooks are there. In all textbook you can see these things, but as I told in my introduction class, all of them have written in different manner, that you have to understand how they are different. Clear? Okay, so we'll see you in the next class. Thank you.